In the next section, we will do hexadecimal into binary and binary into hexadecimal, again by using the table. Now let's see how to make the table. In the previous slide, we saw that we are dealing with hexadecimal and binary conversions. So 2 raised to power 4 is equal to 16. So we will create a table that has 16 rows and the table has how many columns? 4. Why 4 columns? Because 2 raised to power 4 is equal to 16. Once again, the table will only contain zeros and ones. So we can see that the value of each column is represented by powers of 2 starting from right till left. So 2 raised to power 0 is 1, 2 raised to power 1 is equal to 2, 2 raised to power 2 is equal to 4 and 2 raised to power 3 is equal to 8. So the value of this column is 1 and this column is 2 and the value of this column is 4 and the value of this column is 8. And the hexadecimal numbers from 0 till 15 are written here. By using the table, we will fill out the binary values that are equal to those hexadecimal numbers written here. Once done, it will help us in performing the conversions. So now we see how to fill the table with zeros and ones. So first of all, we know that the base of hexadecimal is 16. So we divide 16 by 2. Why 2? Because we are dealing with hexadecimal and binary conversion and binary has the base 2. So we divide 16 by 2 and we get 8. So how will we fill the table? We can see once we get 8, we write 8 times 0. So 8 zeros come in this column. And then write 8 times 1. So 8 ones come to this column. Now this column is filled. Now we will go to the next column. So now we take this number 8 and again we divide it by 2 and 8 divided by 2 is equal to 4. So now we have 4 here. So we will write 4 times 0. So 4 zeros come here and then we will write 4 times 1. So 4 ones come here. Still some boxes of this column are empty. So again repeat the same procedure. Write 4 times 0. 4 zeros come here and again write 4 times 1. So 4 ones come here. Now the column is full. So we will move to the next column. So now we will take this 4 and we will divide it by 2. So 4 divided by 2 is equal to 2. So we write 2 times 0. So 2 zeros come here. And then we write 2 times 1. So 2 ones come here. Is column completely filled? No, the column is not completely filled. So write 2 times 0 again. 2 zeros come here and again write 2 times 1. So 2 ones come here. So carry on till the whole column is filled. 2 times 0, 2 times 1, 2 times 0, 2 times 1. So next we will take the number 2 and we will divide it by 2. So 2 divided by 2 is equal to 1. So now we have 1 here. So in order to fill this column, we will write 1 times 0. So 1 0 come here and again write 1 times 1. So 1 1 comes here. Is the column completely filled? No, the column is not completely filled. So again write 1 times 0. So 1 0 comes here and again write 1 times 1. So 1 1 comes here. So we will carry on this procedure till the whole column is filled. So 0. So 1 times 0, 1 times 1. 1 times 0, 1 times 1. 1 times 0, 1, 0, 1, 0, 1, 0, 1. So now we have filled the table. So now let's see how the values are calculated using this table. So if we want to see how the values are calculated, for example, we want to calculate the value of 1010 and we want to see how this value in binary is equal to 10 in hexadecimal, or you can say A in hexadecimal. Alright. So first of all, we will look at the column 1 and we will see that the value under column 1 is 0. So the value of this box is 0. Next we will see the column 2 and we will see that the value under the column 2 is 1. So the value of this column is 2. Next we will come to this box and we will see that the value under the column 4 is equal to 0. So its value is 0. And next we will come to this box and we will see value under the column 8 is equal to 1. So the value is 8 here. So now we will add them all together. We have 8 here plus 0. 8 plus 0 is equal to 8. 8 plus 2 is equal to 10. And then 10 plus 0 is equal to 0. So the final value calculated from these 4 boxes is equal to 10. So this is how we can say that this value is equal to A in hexadecimal, or you can say 10 in hexadecimal. So this is how these all values are calculated and written here. So we can say that 0 is equal to this, 1 is equal to this, 2 is equal to this, and so on till F. So now we have created the table. So now we will see how to convert hexadecimal into binary first by using the table.